My name is Prithvi Shanath and I am the TA for this course, Engineering Mechanics. I am a PhD student in the Department of Aerospace Engineering at IIT Madras. This is week 4 for this course. We will solve some questions related to beams. I suggest that you should try solving the problems along with me. So this is the first problem. What should be the value of couple M in kilonewton meter such that the bending moment at the fixed end is 0? And the sign convention that should be followed for this problem is mentioned. So, can you first try this problem? You need to find the value of M such that the bending moment at the fixed end is 0. So first what we need to do is we need to draw the free body diagram for this problem. Now for equilibrium in the vertical direction, Fy should equal to 0. So RAY, this end is A, this is B. RAY minus 11.5. So RAY equals to 11.5 kilonewton. Now Fx equals to 0. So this implies that RAX is 0. Now we know the sign convention that should be used. Now for moment equilibrium, what should we write? Can someone tell me what should be the equation? Can you tell me what should be the equation for moment equilibrium? So minus ma, if we consider anti-clockwise direction to be positive, minus ma plus m. This 11 point is causing clockwise or anti-clockwise moment? Can you tell me? Am I audible?
Yes, ma'am.
Okay, so is this what in which direction is 11.5 uh, like in which direction is the moment acting on for this 11.5? It is causing a clockwise moment, right? So it should be 11.5 into this total distance is 10. That should now as per the question, the bending moment at the fixed end should be 0. So MA should be 0, right? For like according to the question. So M should be equal to 150. So the fourth option is correct. Is there any doubt regarding this problem? You can tell me if you have any questions.
Hello? Ma'am, you have taken moment at A is negative, right?
You are not audible properly.
Ma'am, you have taken moment at A is negative now.
You can type in the chat box. I cannot hear you properly. There is only a moment. Yeah, so yeah, load is acting at the end, right? 11.5. It is acting at the end. See that?
Okay.
Now the next problem. The SFD for a cantilever beam is shown. What is the magnitude of uniformly distributed load in kilonewton per meter applied on the beam? So what is the formula which relates the shear force and the load distribution? Can someone tell me? So it is dV by dx is to minus of Wx. So from here, what is the slope? We can calculate the slope from this figure. Y2 is 79.75, Y1 is 118.5, X2 is 2.5 minus 0 minus Wx. So this is minus 15.5. So Wx equals to 15.5 kilonewton per meter. Is this question clear? It's a simple problem. Is there any doubt?
No, ma'am.
Okay. Consider the beam loaded as shown along with the sign convention to be adopted. So here a sign convention is mentioned that you should follow. Can you try solving this problem? First you need to draw the free body diagram. Then find the unknown reaction forces at A and B. Then draw the SFD and BMD. Can you try solving this? And pay attention to the sign convention that you have to follow. It is all mentioned in the problem. can try. Can you tell me what are the reaction forces? 4 and 5. RDY. Okay. RDY is 4. Okay, let's see what we get. So Fy equals 0, RAY plus RB equals to 0, and from Fx equals to 0 we get RAX equals to 0. Yes, that's correct. RB is 5 and RAY is minus 5. Yeah, that's correct. So this is the first equation. Now we can calculate the moment about point C. Calculating moment about C. So RAY is causing a positive moment. So minus RAY into 8 minus 8t. RB is causing a anti-clockwise movement. So plus RB into 8 equals to 0. Minus RAY plus RB equals to 10. This is 2. Now solving. One and 2, we get RB equals to 5 kilonewton and Y is minus 5 kilonewton. So this is the problem which we are solving. Here we need to find the unknown reaction forces and then draw the SFD and BMD. So up till here, is there any doubt? So we got the unknown reaction forces at A and B. Up till here, is there any questions? You can ask me if you have any questions. Okay. So next, for x equals to 0 to 8. Now if we calculate from this end, for 0 to 8, so what sign convention should we follow? It is already mentioned. So on the right face, this is the convention that I should follow, and RAY is acting in this direction. Is there any doubt regarding this? See, the convention is already mentioned in the problem. On the right face, you can see what are the positive direction. Accordingly, I have drawn. So, minus 5 plus b equals to 0, b equals to 5, and for moment, minus m, so this is x, 5 is causing an anti-clockwise moment, so plus 5x equals to 0, therefore m equals to 5x. Is this clear? Up till here, is this clear to everyone? Is there any questions? Okay. So, M is causing a clockwise moment, right? So if I take anti-clockwise to be positive, M is causing a clockwise moment, isn't it?
Yes, ma'am.
And 5 is causing an anti-clockwise moment. So that is 5 into x, 5x.
Okay.
Did you understand?
Ma'am, no, no.
Sorry?
Ma'am, I can't understand.
See, we have assumed anti-clockwise moment to be positive. So,
Okay.
so consider moment about this right face. So, what is the moment that is that 5 is causing? It's a anti-clockwise or clockwise?
Clockwise.
5 about the right face.
Anti-clockwise.
Anti-clockwise. So it should be positive, right?
Yes, ma'am.
And M is already we assumed it in a clockwise direction, right?
Yes, ma'am.
So it should be minus.
Okay, ma'am.
Understood?
Understood.
Yeah, that's how we are getting this. Now for the next part, from 8 to 16. This is 5. Now can you tell me what should be the shear force from this for the second part? Just by looking at it, can you tell me what should be the shear force? So 5 is acting down like in the negative y direction. So minus 5. We have assumed v in the upward direction. So plus v, right? Equals to 0. V is again 5. And for moment equation, 5x. 80 is in clockwise or anti-clockwise direction?
And clockwise.
So it should be minus or plus?
Minus.
Okay. Minus, and this should be again minus m. Now you understood, right? How is it coming?
Yes, ma'am.
Okay. So m is 5x minus 8. Now I'll draw the SFD and BMD. So can you tell me what should the SFD look like? For both the cases it is 5, right? From 0 to 8 and 8 to 16. It is constant, right? So how it should look like? You're not audible. You can type. You can type if you have any questions. You're not audible. Shear force is constant for both. It's plus 5. So it is positive. It's a straight line. Like it's a constant. It's constant in value. See, for both the regions it is 5. It is constant, right? This is 5. you understand why? See, for both the cases, B is 5, which is constant, right? It's not changing.
Yes, ma'am.
Yeah, so you understood, right?
Yes, ma'am.
Okay. So bending moment, it is a straight line equation, right? 5x. At 0, it should be 0. So at 0, it is 0. See, it is 5x. So at x equals to 0, m is 0, right?
Yes, ma'am.
Now it should be a straight line. At x equals to 8, it is, this is 40, right? At x equals to 8 meters, that is the center point. At C, it is 40, right? So this value is 40. Now, from the second equation, at x equals to 8, what is it? Minus 40, right?
Yes, ma'am.
At x equals to 8, m equals to minus 40, right?
Yes, ma'am.
So this value is minus 40. And again it is following a straight line. At x equals to 16, what it should be?
0.
Yeah. So this is the bending moment diagram. So you should always mention the sign convention that you have followed. Now, what is the question? Which of the following statement is correct about the point C? Can you tell me which option is correct by looking at this? Looking at the options.
Ma'am, B, the magnitude of jump in the bending moment diagram is 80 kilonewton.
Yes, yes. So option B is correct. Is there any doubt regarding this problem? kilonewton meter is already given. It's an external moment. It is given in the problem, right?
Yes, ma'am.
An external moment is acting, not a point load.
Ma'am,
So,
how it is
what
acting?
exactly your question is? I'm not understanding.
Ma'am, without any vertical load, why it is acting, ma'am? There is no any load on the beam, ma'am. Due to reactions, it is acting, ma'am. External movement.
What is acting?
Movement is acting. Point C is there, no, ma'am. Why it is acting?
What is acting at points?
Movement, ma'am. Movement.
External moment is already there, right?
Ma'am, how external movement will act, ma'am? Without any vertical load.
External, it is given in the
This
question.
movement means distance.
80 is
Ma'am,
given. It's not
ma'am,
internal.
yes, ma'am.
So what is the question?
Ma'am, you said external means normally movement means force into distance, no, ma'am. There is no force, no, ma'am, at present.
No, it's a moment which is given in the question. Like external force, an external moment is acting. Here, not a force is not acting. Here, moment is acting.
Okay.
Do you get it? Instead of a force, here a moment is acting.
Ma'am, what will cause in that moment?
Sorry?
With this movement, what will cause for the beam, ma'am? It will twist or it will bend.
You are not properly audible.
Ma'am, with this moment, what will cause to the beam, ma'am? It will bend or it will twist,
You
ma'am.
can you type it? Bending, right? It just imagine it is causing bending.
Okay, ma'am.
So 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 this is the next problem. An overhanging beam is symmetrically loaded, and now another type of sign convention should be followed for this problem. Can you notice the difference? Earlier problem, the sign convention used was different, right?
Yes, ma'am.
So can you try solving this problem? Just pay attention to the sign convention. It is different from the previous problem. Can you just try solving it?
Okay, ma'am.
First draw the free body diagram carefully, and then follow the steps. Can you tell me the reaction forces? Can you tell me the reaction forces? So this is the problem. So can you tell me what are the reaction forces? So from Fx equals to 0, we get Rdax to be 0, and from Fy equals to 0, minus 3 plus Ray minus 5.5 plus Rb minus 3 equals to 0. So Ray plus Rb equals to 11.5. Now calculating moment about A. Three into 4 minus 5.5 into 4 plus Rb into 8 minus 3 into 12. So that is equal to 0. So 12 minus 22 plus Rb into 8 minus 36 equals to 0. From there, Rb is equal to 5.75 kilonewton and Ray is also 5.75 kilonewton. Yeah, that's correct. Now, what are we supposed to solve? So, what is the magnitude of reaction force? So, it is 5.75, right? The magnitude Now we are asked to draw, we are asked to find out which is the correct SFD as per the given sign convention. So for this we need to draw SFD. For x 0 to 4, note carefully the sign convention that you should follow for this problem. So from 0 to 4, that is this section, kilonewton is acting here. Now, so minus 3 minus v equals to 0. So v equals to minus 3, right? And from for this moment, this is causing, m is causing an anti-clockwise movement, right? And 3 is also causing an anti-clockwise movement. So m equals to minus 3x. Is this clear to you now? Is there any confusion regarding this? That how am I writing this equation? You can tell me if you have any doubt. Yeah, but I am considering before that. See, I am considering this section up till just before the reaction. The reaction is at A, right? So I am considering a section just before the reaction phase. Is it clear? Yeah. From there I will move to other section. Now for this part, is there any question? For the first section. Okay. So now for x from 4 to 8. Now I'll consider the reaction, okay? So 3 kilonewton, 5.75, this is x, this is b, so this distance is, can you tell me what is this distance from this, from the figure, can you tell me what is this distance? I am considering now up to here. So can you tell me what should be this distance? It should be x minus 4, right? No, this distance. We are considering first any arbitrary distance x from the free end up till here. So I'm starting from this edge, like this is my starting point of x, right? So up till here it is 8. Is this point clear to everyone? So this distance, suppose this is the x. So this distance should be x minus 4, right? Is this clear? Yeah. So that is how I'm getting x minus 4. So similarly for this section also I'll write the equation. So it is minus b minus 3 plus 5.75, that is b equals to 2.75. And for m, plus 3x minus 5.75 into x minus 4, that is equals to 0. So m equals to 5.75 x minus 4 minus 3x. Is there a doubt? Is there any doubt regarding this? Okay. So now from 8 to 12, another section we need to consider. Now 8 to 12 means after this load. Is it clear? Just after 5.5, that section. Now we are solving for that section. So minus 3 minus b plus 5.75 minus 5.5 equals to 0. So b equals to minus 2.75 kilonewton. Is this step clear? Okay. Now similarly for moment, m plus 3x minus 5.75 x minus 4 plus 5.5, this should be x minus x minus 8, right? Equals to 0. So m is 5.75 x minus 4 minus 5.5 x minus 8 minus 3s. x from 12 to 16. So for the last section, you can see from this figure, that means this section, right? Okay. Three, 5.75, 5.5, 5.75. This is B, this is M. So minus B minus 3 minus 5.5 plus 2 into 5.75 equals to 0. So B equals to 3 kilonewton. Is this step clear? Okay. Now for moment, m plus 3x minus 5.75 x minus 4 plus is this thing clear now? Is there any doubt regarding this? Okay. So now we can draw the SFB, right? first section B was minus 3 kilonewton. So this negative. Minus 3. Now from A to this external force 5.5, it was, for the next section it was 2.75, right? So this is 2.75. Now for the next section it was minus 2.75. And for the next section it was three, right? So this is positive, this is negative, negative, positive. So which SFD is correct? Can you tell me now? Can you tell me which SFD is correct? Yeah, the second one is correct. Now what is the maximum bending moment experienced by the beam? Now can you tell me what is the maximum bending moment? You have the equations. Can you tell me? These are the equations, so tell me which is what should be the maximum bending moment? No. At the right end it is 0, right? You need to find the maximum bending moment. So if you plot the BMD, can you just plot the BMD? This is the SFD. Can you try plotting it? Yeah, so what is it? Yeah, just tell me the value. So at x equals to 0, what is m? It is 0, right? And x equals to 4, it is minus 12. So this point is minus 12, right? Just look at the equations that we got. Did you understand? Okay. Now at x equals to 8, it is minus 1. Just can you calculate and tell me what is the value at x equals to 8? Can you tell me? It's minus 1, yeah. Similarly, at x equals to 12, what is the value? It is again minus 12, right? And at end it is 0, right? Can you calculate and tell me if the values are correct. Did you understand how I got this? Is this clear? Okay. Now, what is the maximum bending moment? You can see from this figure, from this BMD, right? It is 12. Is it clear? Is this thing clear? Okay. So, the next problem. A simply supported beam is symmetrically loaded as shown. What is the magnitude of the net reaction force on kilonewton developed at support A? Here also, there is a particular sign convention that you need to follow for this question. Just try to solve this problem. So, for this problem, the total load that is acting on this beam is half into base into height (24 kilonewton), right? Now, since it is symmetrical, see the loading is symmetrical on this beam. So we can say that RA is to RB is to 24 by 2, that is 12 kilonewton, right? So the magnitude of reaction at A is 12 kilonewton. Now the next part. What is the magnitude of the vertical reaction force at B? So we got that RA equals to RB. So RB equals to 12 kilonewton. Now, the correct equation for calculating the shear force at X from 0 to 4. So we need to find out the shear force equation for this section, right? Did you understand? Yeah. So now for X 0 to 4, this is RA, this is B, this is N, and this is the load distribution. Now, from similar triangle consideration, we can find Wx at an arbitrary point. We know that this is 6 kilonewton per meter. So for finding at an arbitrary location X, we can use the concept of similar triangle, right? Now, we know that this end is 6 kilonewton per meter. We need to find at an arbitrary X. So let this be Wx, okay? So now Wx by X equals to 6 by, this distance is 4. This distance is 4. So 6 by 4. So this implies that Wx equals to 6 by 4 x. Up till this point, is there any doubt? Okay. Now I'll write the equations. Minus V plus RA minus half into Wx into x equals to 0. This is the total load that is acting for this region, okay? So V equals to RA minus half Wx. So V equals to RA is what? RA is 12, right? So 12 minus half Wx is 6 by 4 x into x, that is x square, right? So if I simplify this, 12 minus 0.75 x square. So what is the correct equation for V? Which option is correct? Can you tell me which option is correct? Yeah. So is there any doubt in understanding this portion of the problem? Okay. Now the next part, the bending moment diagram for the beam would be which variation with x? Now V is this. How can I find? Now similarly I need to find M, right? So writing equation for M. So M is causing an anti-clockwise movement. So plus M minus RA is causing a clockwise movement. So RA into X plus half into X into WX into X by 3. So if I consider for this portion, this total force would be acting at a distance of X by 3, right? Yes, cubic only. This is how we are getting this. Just see. So the total force would be acting at a distance x by 3 from this end, right? Since it's a triangular loading, right? Is this then clear? Okay. So M equals to RAX minus half into 6 by 4 x cube by 3 that is M equals to 12x minus x cube by 4. So it is a cubic radiation, right? Is this clear? Okay. Now the next problem. Can you try solving this problem? First you need to find the reaction forces at A and B. Now first I'll draw the free body diagram. Okay, so this is AY and BY. AY, AX, 3 kilonewton, now this distance is 1.5 CD, this is E, this distance is 1.5, this is 1, this distance is also 1. Now from fx equals to 0, ax equals to 0, and from fy equals to 0, we get ay minus 3 this is also 3 kilonewton per meter into this distance is 1 meter, right? So total is 3 kilonewton, right? The total force for this uniformly distributed load, it is 3 kilonewton. So minus 3 plus dy, right? equals to 6. Now we will calculate the moment about A. So this 3 kilonewton force is causing a clockwise movement. So minus 3 into 1.5. There is a clockwise movement at point C. So minus 3. At D it is a anti-clockwise movement. So plus 2. And this uniformly distributed load is causing a clockwise movement. So the total distance from A is 5.5, right? Can you tell me what is the distance from the point A for the uniformly distributed load? Yeah. Minus 3 into 5.5 plus by is causing an anti-clockwise movement. So by into the total distance is 6 meters. So 6. So from here we get by to be 3.67 kilonewton and Ay is 6 minus 3.67, that is 2.33 kilonewton. Yeah. Okay. So now what is the question? Magnitude of Ay in kilonewton. So the magnitude of Ay is 2.33 kilonewton. Now the next part of the question, magnitude of By, that is 3.67. Now, the next part of the problem, which of the following statement is or are correct? Now for this we need to draw the shear force diagram. Now for x equals to 0 to 1.5, right? Now first we will consider this section. Is it clear? Yeah. For x 0 to 1.5, now you need to look at the sign convention that you need to use. This is 2.33. So minus v plus plus 2.33 equals to 0. So V equals to 2.33. For the moment M equals to minus 2.33 x equals to 0, N equals to 2.33x. Is this clear? Up till here, is there any doubt? Okay. For the next section, for now we'll consider up till this section, right? So this is 2.33, this is 3, now minus V plus 2.33 minus 3 equals to 0. So V equals to 0.67, that is V equals to minus 0.67. Now for moment, minus 2.33x, 3 is causing an anti-clockwise moment, so it's 1.5 equals to 0, so M equals to 2.33x minus 3 into x minus 1.5. Is this then clear? Okay. Now the next part. That is this section. For x 3 to 4. Point 3 and clockwise moment is acting, which is 3 kilonewton meter. This is V, this is M, this is X. So minus V plus 2.33 minus 3 equals to 0. V is again minus 0.67 kilometer. And for moment, minus 2.33 x, 3 is causing an anti-clockwise movement, right? So this should be plus 3.15, and this moment 3 kilonewton meter is clockwise, so it should be minus, that is equal to 0. So m equals to 2.33x minus 3 x minus 1.5 plus 3. Is this clear? Okay. Now for the next section, that is 4 to 5. This section, this is 3 kilonewton meter, and an anti-clockwise moment is acting, which is 2 kilonewton meter. So minus b plus 2.33 minus 3 equals to 0. So b equals to minus 0.67, and m is minus 2.33x plus 3 into x minus 1.5 minus 3 plus 2 equals to 0. This is plus 2 because it is causing an anti-clockwise movement, right? And 3 is causing a clockwise movement. Did you understand this? Okay. So m is 2.33x minus 3 plus 1. Now for the last section, 5 to 6, for x this is 3 kilonewton to meter, and uniformly distributed load is acting at the end. So this distance should be Can you tell me what should be this distance? Can you tell me what should be this distance? X minus 5, right? This total distance is x. Did you understand? Okay. So, minus b plus 2.33 minus 3 x minus 5 is to 0. B equals to 2.33 minus 3 minus 3 x minus 5. So I can write this as B equals to 2.33 is what? Reaction at A, vertical reaction at A, right? So this is AY minus 3 minus 3x plus 15. So this can be written as AY minus 3x plus 12. So this is what the next question is about. The correct equation for calculating the shear force at x for 5 to 6. So this is the equation, shear force equation, right? You understood, right, how I got this? Yeah, so which option is correct? Can you tell me? Can you tell me which option is correct? Yeah. So now, we'll first, now we need to find the value of bending moment at x equal to 3.5 as per the sign convention used. So 3.5 is like in this region from 3 to 4, right? So we need to use this equation. Do you understand? Like we need to find the value of bending moment at x equals to 3.5. So we need to use this equation, right? Okay. So m equals to 2.33 into 3.5 plus 3 minus 3, 3.5 minus 1.5, that is equal to 8.155 plus 3, this is 2 minus 6, so this is 5.16 kilonewton meter. Now the last part of the question, the magnitude of the maximum shear force experienced by the beam. Now we will draw the SFD, okay? And we need to answer this question also. Which of the following statements are correct? Now we will draw SFD. For the first region, what was the value for B? It is 2.33, right? So up till this point it is 2.33. Now up till 5 meter, it's not changing. See, from this, it is remaining it is remaining constant. Minus 0.67 from 1.5 to 3. 3 to 4 is also minus 0.67. 4 to 5 is also 0.67, right? Minus 0.67. So up till here it is this was 2.33. This is 0.67 minus, this is positive. Now for the last part, can you tell me what is the value? Yeah, minus 3.67, yes. So this is somewhere here, minus 3.67. So this is negative. Now, so then can you tell me which one is correct? The slope of the shear force diagram. Which option is correct? Can you tell me? It is 0 between C and D, right? See, SFD you can see. Between C and D, this is C, this is D, right? So the slope is 0. Am I audible?
Yes, ma'am.
Okay. So the slope is 0 between C and D, right? So the first option is correct. And slope of bending moment is constant between C and D. For BMD, it will have a constant slope, right? This SFD is having 0 slope. So BMD will have a constant slope, right? C. C and D is 3 to 4. The region is 3 to 4, right? So there is a linear variation in X. So the slope is constant, right? Okay. So the third option is correct. And the last part of the problem, magnitude of maximum shear force. You can see from SFD, right? It's 3.67. So the magnitude is this clear to everyone? Okay. So are there any doubts for the problems that we solved today? Okay. So we can stop here if there are no doubts.